All right. Last time we talked about the graphs of sine and cosine, which are basically waves. Okay. Then we talked about how to actually get any kind of wave from a variation of sine. You can have an amplitude. You can have a change of period, which is the frequency, and finally you can have a phase shift. This time, we just want to briefly talk about the graphs of the other 4 trigonometric functions. We will focus on tangent and cosecant. Everything else will be very similar. Okay, so I will leave it to you for you to figure out cotangent and secant using the same procedure. We don't really care too much about cosecant, but we do want to know the graph of tangent, just the trend and some special properties. Okay, so let's start with tangent. Same thing, write down what we know before. We know the domain, try to recall. Okay, it's gonna be from here. It's gonna be everything except for x equals pi over 2 plus n pi. And the reason is because so if you take any number which is 2 pi over 2 plus n pi, your cosine x is going to be 0, therefore undefined. So any number will be working. This one will not be working. And if you think about it, when you plug in this, you either have 1 over 0, okay? At here you have 1 over 0, and at here you have negative 1 over 0, roughly speaking. So not only it's undefined, you actually have a vertical asymptote. At pi over 2 plus n pi. So that's the first thing that came to our mind. The range can be anything. The reason is because the top can be big and the bottom can be very close to 0, so you have some number divided by something very close to 0. You almost got infinity. Matches. Period. Okay. Now we need to think about what happens to tangent. If you think about it, this is the sine of the tangent. That means going from here to here, what is happening? Going from here to here, your sine went from negative 1 to 1. Your cosine actually went from 0, let me write it down, went from negative 1 to 0, and then from 0 to 1. Your cosine went from 0 to 1, and then back to 0 again. So if we just decompose them into 2 parts, okay, from here to here, for your x, your sine actually went from negative 1 to 0, and your cosine went from 0 to 1. So from here you can see you started from almost negative infinity, go all the way to 0, because as time goes by, the top becomes smaller and smaller in terms of a number, the bottom becomes bigger and bigger in terms of a number, so the whole number actually becomes smaller. But then you have a negative there, so therefore you form a negative, very big negative number all the way to 0. Okay, so that's what's going on. Similarly, going from 0 to pi over 2, when your x goes from there. Okay, your sine goes from 0 to 1, your sine increase. Your cosine actually, let me write it down. Okay, your sine keep increasing, going from 0 to pi over 2, it went from 0 to 1. Your cosine actually went from 1 to 0, so your cosine keeps decreasing. So you have a fraction. The top is becoming bigger, the bottom is becoming smaller. So in total, this one becomes bigger. Just keep increasing. Okay. So similarly here, actually your tangent x is also increasing. That's everything we know about the graph. So with everything here, that's the first part, going from negative pi over 2 to pi over 2. Now, if you compare these 2 parts, from negative to positive, and then you have one cycle. Going from here to here, you have another cycle. Okay. And you can verify by yourself. The process is exactly the same because every single thing has a corresponding image or like a partner in the second part. It's the same idea as negative 3 over 4 and the 3 over negative 4. So these two things, they have the same number for different reasons. For one of them, you have a negative, but that is because the top is negative, the bottom is negative. But the other, the top is negative, the bottom is positive, but together you still have the same negative number. From here you can see this one repeats itself in terms of values for different reasons after every single pi, not every single 2 pi. So with that in mind, we can say the period is going to be tangent x plus n pi. Note for other graphs it's 2n pi, okay? But for this one it's n pi equals tangent x. Okay. Therefore, period is going to be pi, not 2 pi anymore. With everything in mind, now we can draw the graph. Number 1, at here it's undefined. At here it's undefined. Okay. This is already a pi. That means for the next period, because your period is pi, you just repeat what happens in here. And before, you just repeat what happens within this one. So really we just need to figure out what happens within this. Okay, then you repeat that thing for infinite many times. Finally, starting from here, we have already did the analysis. Going from here to here, this one start from 0. In the first quadrant, which means from 0 to 2 pi, 0 to pi over 2. Like we said, the top went from 0 to 1, so it keeps increasing. The bottom keeps decreasing, so together the whole thing increases really fast. And eventually you almost have a 1 over 0. Therefore, you have something like that. Following the same logic, we can argue the second part goes like this. We have the vertical asymptote. We have an increasing curve. And we have this one repeating itself after every single pi. So if that works, this works. If that works, this works. That will be the graph of tangent x. So in the exam, if I ask you to draw the graph of tangent, again, I need you to show the following things. You need to show the vertical asymptote at plus 2n pi. You also need to show me that this one has a period of pi. So I think the best way to do it is draw the vertical asymptote, draw the graph within from negative pi over 2 to pi over 2, and then repeat that thing for once to the right, once to the left, so I know that you understand that this is going to be a period of pi. Okay, so that's the graph of the tangent. For cotangent, following the same argument, check decimals. Use some graphing calculator or decimals to draw it. And ask yourself, well, how did you came up with this graph? It should be very similar to what we see here, because tangent and cotangent is kind of like a partner to each other. All right. The second thing, we have cosecant and secant. Again, we go over cosecant. For secant, you go check decimals, following the same logic, and try to see if you can draw it by your own. So what is cosecant? Well, we don't even have to do anything, because it's basically the same as sine, but flipped. So if you could draw sine, you will probably see what cosecant is. So if sine repeats itself after every 2 pi, cosecant of course repeats itself after every 2 pi. Now let's look at several special points. Number 1, at here and here, okay, your sine is 0. Then 1 over sine is going to be undefined. Therefore, you have a vertical asymptote here, vertical asymptote here, and a vertical asymptote here for one complete cycle. Okay. Now here, you have your biggest sine x, which is 1. Okay. Therefore, you have the smallest cosecant. Remember, you flip it, which is your cosecant, which is 1 over 1, which is also 1. Okay. Similarly, here you have the biggest negative number, which is negative 1. Finally, let's check quadrant 1. You start from some vertical asymptote. Your sine is 0. As your sine becomes bigger and bigger and bigger, your cosecant, which is 1 over sine, becomes smaller and smaller and smaller until you reach the biggest sine, which is the smallest cosecant. For this part, you repeat your sine value, then you repeat your cosecant value. Similarly, you can check. That will be one complete graph of a cosecant in one period. Now to show it continues forever, try to write down this is 3 pi, this is 4 pi. Okay, and then you will have the same thing. Repeated. So that's the graph of cosecant. Okay. Again, in the exam, what do you need to show? I think the points which are important will be the peak, which is 1 pi over 2, 1, and 3 pi over 2, negative 1, which means this point and this point. That would be very important. So we know what's the smallest value and biggest value for the negative part. You need to show the vertical asymptote. From here you can see it happens at where sine equals 0. So that is going to be n pi. I would say the third one is to try to show the period is 2 pi. Okay, because sine repeats itself after every single 2 pi. Cosecant, which is 1 over sine, also repeats itself after every single 2 pi. That's it. That's the graph of cosecant. I would say for secant, check Desmos by yourself. You will again have something very similar to what you have here. If you think about it, right? Think about the relationship between sine and cosine. You know, why is this wave and cosine is nothing but the same wave shifted to the left by pi over 2. You got cosine. Then for cosecant, which is 1 over sine, if you shift this whole thing to the left by pi over 2, you should be able to get the graph of secant. Because then sine become cosine, 1 over sine become 1 over cosine. Okay, I will leave it to you for you to think about it, but the graph will look very similar to what you have here, except everything shifted to the left by pi over 2. All right, this whole section is just to complete what we had before. Technically, we don't draw the graph of secant and cosecant that often, but you do need to know the very detail of how to draw the graph of tangent x. This is very important. So this graph. Very important. So if I were you, I will spend some time here and try to figure out how to get the graph, the same process I did in class. okay? How to get the graph of tangent x for once. Then after that, you will know how we got it.